Lesson 41. I can find a pattern to calculate the sum of fractional parts. Please open your light purple problem-solving book to page 83. For our first problem, we're finding the sum of 0/3 plus 1/3 plus 2/3 plus 3/3. So we know that if we take 0/3 and 3/3 and combine them, we get 1 whole. And if we take 1/3 and 2/3, we would get 3/3 and once again 1 whole. So when we take 1 plus 1, we get 2. Once again, we can start by combining 0/4 and 4/4 to get 1 whole. And then we can combine 3/4 and 1/4 to get 1 whole. And we're left with 2/4. So we have 1 plus 1 plus 2/4, or 2 and 2/4, which simplifies to 2 and 1/2. For 0/5 plus 1/5 plus 2/5 plus 3/5 plus 4/5 plus 5/5, we'll start by combining our 0/5 and 5/5 to get 1, and then we can combine our 4/5 and 1/5 to get 1 whole, and our 2/5 and 3/5 to get 1 whole. So we have 1 plus 1 plus 1 equals 3. Once again, we're going to start by combining 0/6 and 6/6 to get 1 whole. We'll combine 1/6 and 5/6 to get 1 whole. We will combine 2/6 and 4/6 to get 1 whole. And we are left with 3/6. So when we add them together, we get 3 and 3/6, or 3 and 1/2. Now we're adding together sevenths. So we're going to start with 0/7 and 7/7 equals 1. 1/7 and 6/7 equals 1. 2/7 and 5/7 equals 1. And then we have 3/7 and 4/7 equals 1. And we don't have anything left over. So we have 1 plus 1 plus 1 plus 1 equals 4. For eighths, we will start with 0/8 and 8/8 to get 1. We'll move to 1/8 and 7/8 to get 1. 2/8 and 6/8 to get 1 whole. 3/8 and 5/8 to get 1 whole. And then we are left with 4/8. So we have 1 plus 1 plus 1 plus 1 plus 4/8. Or 4 and 4/8, which equals 4 and 1/2. Please pause the video and take a look at what you wrote down for number 1. Notice any patterns that you see. Pay attention specifically to when you have an even numerator or denominator and when you have an odd denominator. What are the differences you see? Let's start with odds and evens. You should have noticed that when adding sums of fractions with even denominators, the answer is not a whole number. There is 1/2 left over. So for example, when our denominator was 4, we got 2.5. But when our denominator was 3, we got an even number of 2. The next pattern you might have noticed is that to find the answer, you can take the denominator plus 1 and then divide that sum by 2. So for example, if you were working with fifths, you would take 5 plus 1 equals 6, and then you would take 6 divided by 2 equals 3. Check the problems that we did for number 1 using this strategy. Pause the video and push play when you are finished. Let's practice the strategy we just talked about with sevenths. If we were adding 0/7 all the way up to 7/7, we would take our denominator of 7 and add 1 to get 8. And then we would take that sum of 8 and divide it by 2 to get 4, which is what we found when we added the numerators together. The next question asks, how would the sums change if the addition started with a unit fraction rather than with 0? So for example, instead of starting with 0/3 plus 1/3 plus 2/3 plus 3/3, it would take the 0/3 out and start with the unit fraction of just 1/3. Would your answer be different? Pause the video and think about that now. You should have come to the conclusion that your answer would be the exact same because you should have come to the conclusion that the sum would not change if you took out the 0/3. Let's apply this strategy for number 4. If we're working with 0/10 adding all the way up to 10/10, we would start by taking 10 plus 1, which equals 11. And then we would take that sum of 11 divided by 2, so we would get 5 1/2. If we're adding 12ths, we would start by taking 12 plus 1 to get 13, and then we would take 13 divided by 2 to get 7 1/2. Try this problem on your own now. Pause the video and push play to check your work. You should have got the answer 8. Try this problem on your own now. Push pause and then push play to check your work when you are finished. If you got 13, you are correct. Pause the video and try this problem on your own now. Push play to check your work when you are finished. You should have got the answer of 25 1/2. Try this problem on your own now. Pause the video and push play to check your work. Did you get 50 1/2? If you did, you are correct. To solve these problems, we used a strategy of adding 1 to our denominator and dividing that sum by 2. Do you think that you could apply this strategy to find the sum of all the whole numbers from 0 to 100? Pause the video and think about that now. Yes, the same strategy can be applied to find the sum of all the whole numbers. We add pairs of numbers together. So for example, for 100, there would be 50 pairs. That's 5,000 plus the middle number, which is 50. So if we had 0 all the way up to 100, we know that we would have 0, 1, 2, then we would have 98, 99, 100. So we would pair up 0 and 100, 1 and 99, 2 and 98 to create sums of 100. So then we would have our middle number, which is 50, that we would have to add to our sum. So we would get 5,050.